Hey everyone, I'm going to talk about data trees again. So zooming out on Miro uh, over at the template, this is where I made everyone's names in the sort of middle left and right of the room. So I'm just going to copy all three of these into my Grasshopper, which I already have open. So let's do my vocals here at the top. And then // for a panel. Just going to paste the names, go back the middle, paste the names, and get this. So when I have things in a panel, they automatically load in paragraph format, which means this is just like one long continuous piece of text. And something that has to be done very often is changing it to multi-line. This means that when there is a return or an enter, a new line in that text, it's going to make it into a list format, and these will get numbered on which item they are within a list. And this is sort of an ordered list, as what we called in computer programming. So if I do list item, which we did before, just as I can select from any ordered list of geometry, I can select from an ordered list of any data, including text data, which is what this is. And now I can see that the zero item, the first thing on the list, so zero is Hannah, Kate, sorry. If you want to go really slowly with a slider, hold down Control, and it allows you just to kind of slow down, especially when you have a big slider. Now I'll move just one by one. I can see there it's selecting different names on the list. Actually, I think I copied the same thing twice. Okay. And I'm just going to switch this. Okay, so now I want to make this into a data tree. And I mentioned in class that merge and entwine are similar but different. So I'm just going to do a merge here as well, which I didn't actually do in class. And also entwine. Okay, so we can investigate what's going on with a panel. So merge in this case has just made one long list, combining them. But entwine has made, if you see there, different branches, where the first branch is called 0, 0, the second branch is 0, 1, and the third branch is 0, 2. And on the first branch is 12 items, then 14, then 6, right? And it's because there's a different amount of people in each of the lists, which is, a different amount of people in each of the rows. So what I want to do is copy this data structure and make lists of points in the same data structure so that these two lists can match each other. And when they match each other, then I can also match geometry to those lists and control using these lists to do really specific geometric commands. Okay, so let's get rid of the panels and create a grid of points. I'm just going to use a rectangular grid. And I will do 100 on the size of each grid cell. And then 10 should be enough for, so I'm going to delete a lot of these points. And I don't want to bake that directly because it has both points and curves where they're the grid cells. But if I bake this, that means I'm sending these coordinates into Rhino. It's choosing me what layer I want to save it on. And now I can turn this off, right? So now these are in Rhino for me to select as I want. And if I compare the seating chart at where people are sitting, I can see Caitlin's here at the back, creating a sort of extra row compared to the other two. So let's start from, that's going to be Caitlin there. Oops, I guess one over. Okay. And I mean, this is kind of easier to line up in a flat view, but I can still probably manage hit most of them. Hit far in the middle. Yeah, I'm just going to copy, say, 4x2. If I just want points that line up to these kind of positions. I don't need this probably here. So now I can create points in Grasshopper. I'm going to link these back in, and I'm going to make them as 3 branches, and I'm going to match the order of the names. Now, I typed in these names earlier where I went sort of from a row starting from the left, sort of starting from 0, 0, 1, 2, 3, 4, 5, then 0, 1, 2, 3, 4, 5, 6, 7, 8. So I'm gonna that's the order I put the names in the list. So that's the order of these names on this list. So I'm gonna copy that with the points. And okay, so set multiple points as opposed to set 1 point. So set multiple points, and then I need to go 1. And if the names were in a different order, you just select these points in a different order. That side, middle, here. If you normally had points and you wanted to select multiple points, you could just drag it over like that, but you wouldn't know the order, right? I'm very careful about the order here because now I'm going to line up one branch to another branch, right? So I'm going to delete the merge because I don't want a flattened list. I want this data structure with the branches 0, 0, 0, 1, 0, 2. And I want to do an entwine on the points, which creates them into a data structure where they're going to have the same matching branch structure. And there's a component called a param viewer. And that just lets me see the data structure. It's going to be kind of simple now, but as we add more data to it, more branches, it will get more complicated. So you can either see it in that view or just double click it. And I can see now that I've basically 3 branches with different things on them. And this is the same. Reorganize a little bit. Okay, so text tag is a component we saw before of just writing text onto the screen. If I internalize these points, that means they're no longer referenced from Rhino to Grasshopper, but instead just saved directly in Grasshopper. So now I can delete these and they're sort of saved here. That's only after I internalize. So then these are points. These are going to be the location of each of my text tags. And this is the names. This is going to be the text. Better to have this appear. Okay, it's neater. So now if I zoom in, it's created. Wait, Sophia's mentioned a lot of names there. I think I have too many points there. I don't think I copied it right. Oh yeah, I was meant to delete some points. So let's fix that. Yeah, I don't think I can do it that way. Okay, I'm going to bake the points and just redo it. Bake those points. You can see that they're now there. I'm going to delete those points. Now, if I select multiple points, it will just rewrite them. And I can go here. You can do it. Let me just clear the values. So I can do clear values to empty this out. And then set multiple points. And there we go. See the error. Okay, and that's kind of, I guess, proving data structures are important. So internalize this data, delete this points, and now let's turn all this stuff, preview off, Control Q, and difference is fine. Okay, now let's see. That looks right for that side of the room. That looks right there. That looks right. Looks right. Yep. Okay. So all the names lined up to the right place. And that's because we have 3 branches of points. We have 3 branches of names. And it's basically just matching the 12 points on the first branch to the 12 names on the first branch of the second item. And everything's lining up. If I wanted to just change the color there, I can just type black, or I can do a color swatch or parametric, and that controls that text there. Okay, so the next thing is to do 3 different shapes. I can't remember what I did in class, so I'm just going to do a sphere, a cone, a cylinder, but I don't know what order I did in class. So, and some of these are going to be open, so I can just cap them. So in the case of the cone, that means it's got a floor surface on it, and the cylinder will have a top and a bottom if I cap. And I remember I need to set a radius. So I'm just going to make that. So each one of these names is 100 apart. So I'm just going to use a number slider, and I might change it later, but that can be the radius of the cone, radius, the length of the cone, which is height, the radius, and the length, which is also the height of the cylinder. So I'm just going to make everything 100. And those are over there, but they're all on the 0 point. What I want to do is I want to move all of this geometry to match it with this. So first thing I can do is entwine these, giving them a data structure as well that matches the other data structure. The only difference is this data structure only has one thing on each list. See there, 1, 1, 1, where this has 12, 14, and 6. What's going to happen there, it's just going to apply the one thing on that list to the 6 names or 6 point positions in that list. And technically move is looking for a vector, but all points are vectors from 0, 0, 0. So if I have a 100, 100, xy, that is also a vector from 0 to 100 to 100. However, if I was from 100 to 100 and I had a vector starting at 100, 100, going to 200, 200, then the point 200, 200 is a vector from 0 to 200, 200, not from 100, 100 to 200, 200. So that would not be equivalent. But I can, given all of these points are just relative to the 0, 0, that means I can use them as my vectors and use these as my geometry to move. And make this a little bit smaller so that things line up. And we have spheres over here, cones, and cylinders. So it sort of took one data tree, split into 3 branches, and another data tree split into 3 branches of the points, and was able to match them. I might just double the height without making an extra component. I could do multiplication by 2, or I could just go here, expression, and just do x asterisk 2, which we'll just multiply by 2, and you see those got a little bit taller, and do the same thing here. So expression x multiply, or asterisk 2. And now those cones are a little bit taller. Perfect. I could move those spheres up. It doesn't make much difference. But if I wanted to move them up, I would just move the sphere up here a unit z direction by, let's say, half the length, or maybe the full length, actually, because this is sort of a radius. So I'd move them up by the radius, and then they'd be flat on the ground. Or just do it since, take it a second. Move unit z. So I want to move them by unit z. And here's something I haven't mentioned before. If I want to just move, sort of make a sort of kind of split in the canvas, hold down Alt, and I can just move, and it just moves everything, the whole thing. It's just going to create extra space. So given I decided this last minute, I'm going to sort of do that Alt drag to create extra space. Whoops, right. So I want to move the sphere by the radius. And then that is going to be my new shape 1. And did that move? Yep. So now it's sort of sitting on the ground. Perfect. Okay. So in the file, it would take a really long time to do, but in the file that I uploaded to the file section of Canvas, I then went in and separated each of the rows into separate rows, entwined them, and then re-entwine them again into the sort of left, middle, and right. And you can kind of open that file and just see how that would work. There's a little complication on flattening and grafting in order to get that to work, but it does make it a little bit more complicated. But if anyone has any questions on that, just ask me in class or after class or whenever. So this is kind of a good enough standard to get to. I don't think the sort of example is necessary to learn, but I think this amount is basically a data tree where we had to have 0, 0, 0, 1, 0, 2. If I was to separate them even further, I would get sort of an extra number here and an extra semicolon, and therefore I'd have, let's say over here, this would be 0, 0, 0, then 0, 0, 1. And yeah, I might show you, I think there's a later one I'm going to add. So what does flatten mean, which was kind of mentioned before but not explained? So if you see there, I have 3 branches, 12, 14, and 6, right? So if I do list item on, and this is the shapes, I get the first item on the list. And if I want to change the number, I change the index, I. So let's make this 0 less than let's say 12, I think is the biggest row. Okay, so I see this goes there, right? And it's selecting the first or the second, the third item on each of the branches, right? Where if I flatten this list, so if I see what that looks like in the panel before I flatten it, you can see that I have my 3 branches, and they have different. So the untrimmed surface is the sphere, and the other 2 are closed pieces. So if I flatten this list, it just, in the same order, just makes it one long list. And now if I was to do a list item, this is now the whole list, which we kind of started over there. Right? And if I kept going higher, it would just keep going through the names and the shapes. Graphed, on the other hand, is the opposite of flatten. So graphed, if I have this flattened list and I make a geometry container just to store it somewhere. So let's just turn things off. I will leave the names on. Okay. So if this is flattened, graphed would put everything on its own branch, which is why you get all these separate. So this is branch 0, 0, 0, 1, all the way to the end. But if I remove this flatten, now it kind of looks like they're on their separate branches, but they're not quite. So if you see 0, 0, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, and then the 1 changes here. So that means those 11 are on separate branches within one branch, like as if it was a folder structure. And all of these first 11 items are in a folder, but then all of them are in separate folders after that, one level deeper. So if I take the param viewer, I can see what that looks like. And there you go. So I still have my 3 branches, but then I have separate branches for all of the items in the branch. And getting good at these data structures is important just to learn how to manage data effectively. And I kind of showed the example that we'll hopefully do after we finish the bridge from Burning Man, where when you look at this is a curve. That curve is divided into a number of points, and then each point is connected to a point one above on the branch next to it. So these are all curves, and it's just a list of points, a list of points, a list of points, and managing what number, like if this is the 6th point and this is the 7th point, then 6 point connects to 6 point, but 6 point also connects to 7 point, and 7 point here connects to 7, and 7 connects to 8. And when we get to do this, I'll put all the numbers there, and you can see the numbers on the screen and see sort of this data management of points. And this would not really be possible to build without Grasshopper. Okay. So after that, I think I just went back and sort of revised series and range. I'm not going to re-explain them now because I think if you want, there's a previous video on series and range that you can look at. One thing I sort of added at the end, which I also explained dispatch in that last video, but I'm just going to do the example that I did in class. So if I take a circle, and let's just go down here. If I take this circle and I do a radius of 100 and turn everything off so that I'm just focused on this circle project. So I think it's just that and this. Okay, so I want to move this circle and I want to move it vertically. So unit C. And if I give that a number, this is how much I'm moving it in the z direction. So that is the equivalent of 100. Make it, say, 300. I'll just leave that at 100 and just make this 33. Okay, so that now there is, move this 100 there. If I'm to do series here, I can use series to have a start position, which I'm not going to change, but that's just what is the first number. And how many total numbers should I use, and what is the step between each? So as explained in class, that I'm not controlling what the highest number is here, but I'm just saying every time you go up by 8, or they go up by the step, and do that 25 times. So the highest one here will be 25 by 8. Should be around 400 or so. Oh no, my math is totally off. Sorry, that would be 8 by 50. 8 by 25. And I think you also have to include that the numbers are starting from 0 and not from 1. So the biggest one is 192. So range is a bit different, where I am setting the sort of maximum value. And I spoke about doing construct domain. And in this sense, I can control the top and the bottom of the domain. And then how many steps between. So this is the maximum. And this is how many sort of divided between. So if I change this to domain, so this is my maximum, there's 100, and then this is how many circles will appear between the two, because they're just numbers that are between the range, between the domain of 0 and 100. Then very similar command is random, and random again takes a domain. I can just copy the domain there. And how many random numbers to generate. And let's just start it as 1. I kind of never want that to be 0. But anyway, one random number, which in this case is 77.1. I want it to be an integer or to round it. So I can just do either the round command or the int command. And now it's a round number. And there's random numbers. So then you can see it's kind of like repeating itself, or kind of getting kind of close. And I said that we could sort the list with sort list, and we're just going to use the k. So that won't actually make a difference, but if I was to examine my data set, I could see there that this is 77, 40, 17, where this is 1, 1, 2, 3. And that's nice that we have this repeat number here. One of the problems of having random component and not random integer component is it's repeating itself by doing 0.9 and 1.1 and then just rounding both of them to 1. And even though they are different floating numbers, when you round them, they're the same round number. So create set is one of the ways that can remove the sort of duplicate numbers. So I can see what the set looks like, and it just removes the double 1 or any other doubles. So you can see this has 44 numbers where this one has 60. So there's actually quite a lot of repetition in there. And this is just the list of numbers going into the Z coordinate. And there we are doing that. So now dispatch. Dispatch is a way of using a pattern to select different items. And I might just switch this back to range and increase the amount. So dispatch is going to separate using a pattern the list into A and B. And what it wants to accept here, the default is true false. And currently, like, it's showing both A and B, which is why when I select it, everything is selected. But if I could put other things other than curves into here. I could put surfaces. I could put any type of list. But I only want it to show. Those curves. So let's turn this stuff off so that I can see stuff. Control Q. Okay. So give me a bit of space. So if I do a list and I write true, true, false, this is currently just a continuous paragraph until I do multi-line. Now it's a list, true, true, false. You can see that this is now here. Green, green, red, green, green, red, green, green, red. Curve selected, which is the greens, right? So true, true, false, true, true, false. And I could do more of these if I wanted. And now see what's selected. And now I get 4 greens and a red, 4 greens and a red, matching this true, true, false, false. Okay. So if using a series, I can, or using repeat data, going to do the same thing here. I can say that the start is 0. The step size, I'm going to just change the numbers directly here. Step size is 0. So on each time that you go up, don't go up at all. Just stay on 0 and generate 10 numbers. So that's 10 zeros, right? 10 zeros. And let's do a number between 1 and 20, 1 less than 20 to do that slider. And I can see that gives me this pattern of 1 0 or 7 zeros, right? Well, 6, but 6 plus 0, so 7. And I can merge that with 1 1, because zeros and ones are interchangeable with true and false, right? So now this is true, false, 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 right? And in this example, it doesn't really matter if it's a whole bunch of falses or a whole bunch of trues, but there. So now I can put this here, select this curves, and then move this slider. Let me. Oh, I didn't flatten it. So you can see there that they're on different branch structures. So there's the 1 and then the 7. I could either flatten that there. Does that make a difference? Yes. So now I can see that it's, I could have flattened it here either. Makes no difference to flatten both. But I can see now it's 1 0 0 0 0. Okay, perfect. So now when I select this and I select the slider, I can see I'm selecting different amounts there. So this is really small. This is big. Okay. And we kind of ran out of time in class, but what I was going to do afterwards was to scale only the ones that are in the A pattern, say, right? So to scale it, I need to find the area to get the center, so I can scale from the center of the line. And then the reverse of dispatch is to weave, right? And I want to use the same pattern as the weaving pattern. So whatever this is going to be the separation pattern, I also want to be the pattern to put them back together. And sometimes this is reversed. So the pattern they're going to come back in is 1 0 0 0 0. So I want this. Yeah, I want this to be the 1 and this to be the 0. Let's move this up so it's a bit more clear. Okay. And let's also change the scale factor from 0.5 8 less than 1 point, have a couple decimal points, right? So it can scale to 80% its size or less, because I don't want to scale it too much. And then let's just check before we do anything that these are actually in order. So list item. And let's do 100. Okay. And if they're in order, this should go up from the bottom. I think they're in order. Yep. So because they're in order, then I can loft them together. All these curves to make a surface. And there is my surface. So if we scale this down, that will create more of a pinch there. And if we change this now, this is changing how many get selected. So this is every curve. Let's just have a look at the true false pattern. This I don't need anymore because I'm not using it. And let's see. So this is true, false, in that pattern. Where if I go here, this is true, false, false. True, false, 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 false. And you kind of see how it's changing in 3D. And that's basically how we can use true and false to select certain items, then scale the ones we selected and bring it all back together to loft them. All right, if there's any questions, just message me or comment on the discussion post or get in touch somehow. All right, see you on Thursday.